Hey, what's up guys, my name is Cherno. Welcome back to another code review, the series in which you guys send me your code and I take a look at it. Now this time, we're doing something we've never done before. We're actually going to be looking at the same code we looked at last time. Why? Because it was so good that I just couldn't get enough of it. The reason being that we only really took a look at half the code because I got too distracted talking about memory. Don't you hate it when that happens? Talking with your friends and then suddenly just start talking about memory and just can't stop. So yeah, we're back at it again with this physics engine. The previous video I will have linked up there. Definitely take a look at it first, especially if you're interested in memory and performance and that kind of stuff. In fact, one of the reasons why I really like this project is because it actually gives us a few actionable items to maybe fix and improve and optimize. And me as a boss/manager, I like actionable items now, I guess. So what I'm going to try and do here today is take a look at the code that we haven't taken a look at yet, and I'm going to abstain from talking about memory, I guess. But in the future, we might revisit this code and implement some of those optimizations that I've talked about, so we'll get back into it maybe someday. So don't be too upset. There. Okay, so taking a look at the Solution Explorer, once again, we can see that the project is divided into a demo and also this Stowe physics engine module over here, which compiles into a static library. This is the actual physics engine itself, it looks like, and these are just things that are used for this demo. So this is what we're going to focus on. We're going to see how this comes together. Now, when you're looking through code that isn't your own, it can be a little bit difficult to piece it together in your mind, especially if you're a beginner and you just don't have much experience. What I'm going to do is I'm going to show you how I approach something like this, even though this is a relatively small code base and it probably wouldn't take you too long to just like read each file and learn about how they work. I mean, this isn't including the header files. Why isn't it including the header files? Like, again, this is some CMake configuration, but each one of these, if I just hit Alt-O using Visual Assist or Control-KO using just Visual Studio's commands, you can see there is an HPP file. However, that's like coming in as like an external item. See, this is, I don't know, the project structure is a bit weird. I don't know like exactly the CMake configuration you've used here. I don't really care, to be honest. But yeah, usually like it would be good to see the header files here, especially because header files don't necessarily have to have a CPP file along with them, right? They could just be a header file, in which case I might be missing entire files from here. Like, you can't assume that if you have a CPP file, you can just switch to the header file and you'll see it, and therefore you don't need to display them. Like, you definitely should display them here. The reason why, by the way, they don't really need to appear here, because this is actually a list of files that are included in the project. So if the files are not included here, they're not sent to the compiler. Header files are not really compiled. Header files are included into CPP files. So we have like this vector2.hpp file, for example. It contains all of this code, beautiful, but it only gets compiled when it gets included into, well, this is actually manifold.hpp. So I guess that gets included into manifold.cpp. This is the file that is sent to the compiler. Same reason why if you go to a header file, you hit Control F7, which is the shortcut to compile a single file. Or if you're cool, you could actually go to add, remove buttons, customize. This is a bit of a tangent. And you could add command to build compile, right? So I think it's also build compile or something. This is actually a nice button I like to have here. Here it is, this little compile button. You can see it's grayed out and Control F7 won't do anything. If I switch to a CPP file though, it's not grayed out anymore and I can click it and it will just compile a single file. So that's why we don't actually even need the header files included in the project, because as far as like the C++ compiler is concerned, all it does is it simply goes to this file path, assuming that that is relative to a compiler include directory, or relative to this file itself, and it just copies and pastes the contents of that file. And it does so recursively going through all of these. Just became a C++ header file tutorial. You're welcome, although I do have one of those that I filmed outside in some park. So check that out for more details. It's becoming less of a code review and more just a Cherno talks about programming. Oh well. So how do I approach going through this project and I guess learning how it works? Well, the number one thing I can recommend is to just use the actual debugging tools that are inside your IDE. So I could just read this text, right? I could just read the fact that the main function calls demo balls and cube, right? Which is a class, and it calls the run function. I can use the tools inside my IDE to just jump to that function and then just learn about the structure and how it kind of stems down into all of these functions just by visually reading and navigating using the IDE kind of navigation tools. That's cool. What's cooler is just running the program and then using like breakpoints and various other, I guess, code like execution flow commands, like step into, step over, that kind of stuff, to actually see what happens. So here's an example. I could put a breakpoint in here, just setting that using F9, then I'm going to hit F5 to run. Actually, before I do that, let me just switch to debug mode, because if we're not in debug mode, the compiler will optimize and inline and do a whole bunch of stuff with our functions. and we just won't be able to see like half of what's going on. So let's go ahead and hit F5 inside debug mode, and you can see we have a breakpoint here. Let me just permanently display this here. We know that we're running this, but what does this call? Oh, I'll just hit F11 or go up here into the step into button. Now, if you're not using Visual Studio, the kind of terminology is virtually identical in any debugging environment. So you'll have an equivalent for sure, unless you're using like a pile of garbage. All right, so step into, if I click that button here, you can see we're now in the constructor. And now if I'm here, what I can do is I can continue kind of stepping into, which will probably take me into like some of these things. Like, let's just try that. Yeah, it'll jump up here and that's all cool. And then maybe it will take me into like, yeah, the constructor of context settings, whatever. If I don't really want to keep going kind of depth first everywhere, and I just want to go almost breadth first, even explaining this, I'm acting like a programmer. But whatever, let's just say you want to step onto the next line without actually going into the function or the constructor or whatever, there is a step over button or F10, right? So usually I use like my keyboard shortcuts for this. So F10 is step over, F11 is step into, Shift F11 is step out, which is a good example of what we'll use here. You can see because I already stepped into context settings, if I just hit step over now, it's going to keep going through all these members that it's initializing. But if I hit step out, which is Shift F11, then it will take me out. So it's going to run the entirety of whatever scope or function I'm in, and then it's going to step me out into what called that function in the first place. And that's what I've done here. And then I can just hit F10, and you can see I'm going through all of this line by line. Now, one other cool thing you can do that some people might not be aware of is you can actually take this is our kind of instruction pointer, and we can actually just drag it back. And what it will do is it will run that code again. Now, it does display a little warning saying that to change which statement is executed next, drag the arrow. This may have unintended consequences. The reason why is because it's not like it's going to roll back the program and undo any changes that have been made as a result of running those CPU instructions. They obviously have already run. Yeah, if I just hit F10 a couple times, I've physically run the code on my CPU that is inside like whatever functions or code I've written. That's already been called, that's run, that's executed. If I drag this back, I'm now executing it again. So if I had a function that added stuff to a list and it's added 5 elements to a list, I drag this back and I run it again, I'm going to have 10 elements in the list. Right? It's going to run that code again. It's not going to undo anything that's happened. That's why sometimes it can have unintended consequences. However, in a lot of cases, for example, here I'm just obviously making a unique impulse solver. I'm making a new object and I'm overriding the previous instance, assuming the constructor of this doesn't do anything. I mean, this doesn't even have a constructor unless it calls, yeah, it doesn't do anything, right? All it's doing is allocating memory. If I drag this back here, it's just reallocating that memory and like freeing the last result because I'm like replacing the unique pointer essentially. So I can run this like as many times as I want and I'm not going to get any consequences like happening from that really. Same with this smooth position solver, that doesn't really do anything. So this is personally something I use a lot. So for example, like why would this be useful? Let's just say I'm just going through this F10, 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 and let's just say this doesn't work. Load from file doesn't work. I end up like in here. I might want to step into that function, but I've already like passed over it. No, I can drag that back and now it's actually going to try and load it again. And this time I can hit F11 and I'm going to end up inside this load from file function eventually. Now, here's another little trick that might be useful. Sometimes you just can't find the entry point. Now, in a program this small and like with this layout, it's pretty easy. I mean, the file is literally called main.cpp and it's got this. And even if it didn't have this, you could probably just hit Control-Shift-F and just search for like main or int main or whatever and find it, or winmain if it's like a Windows application with that entry point specifically. There's ways to find the entry point. It's generally pretty easy. But what you could also do, right? Let me just close like everything. So pretend I don't know where the main function is at all. Nothing exists here. Blank Visual Studio solution. Instead of hitting F5 to run, I can hit F10 or F11. So step over or step into. So let me just hit F10 right now. You can see it started to build and look at this. It's opened up main.cpp at the very kind of entry point of our application. Now, this might not be the entry point of the application because, for example, had this person written some kind of static initializer like this, right? If I hit F10, you can see it's still taken me to this section of my code. But that's actually not the very first code inside our application that was called. Because if I go into demo balls and cube and I put a breakpoint like, I don't know, here, sure, whatever, and then I hit F10, oh, what a surprise. I ended up on my breakpoint here and not over here. And if we look at the call stack, we can see that there's actually some dynamic initializer for game 2 that's been called over here, right? And that's actually coming from this kind of common main function. And we actually haven't even called this yet, right? We're still here. And if I hit F5 from here, we end up on this line of code, right? So sometimes there's code that runs before the main function. This whole main is the entry point, is potentially a lie depending on how you look at it. So my point being that this kind of like F10 to run might not necessarily be the first code that you run inside your entire application. It's more so a way for us to actually kind of find our entry point and start executing from there. Now, if I hit F11, it's going to do the exact same thing. And if I put this back and hit F11, same thing again, right? So it's not going to go like into this and start executing that. It's going to just show me my entry point. So that's a really easy way to just find out where your entry point is. Like if I just open up the Unreal Engine solution and I have no idea where on earth main is, and in fact there might be like several mains depending on the current configuration and all of that, I can just hit F10, it will take me there, done. And from here on out, you can just go through and just see how the program works. Cool, it's adding all of these things. So this is physically like what is happening with my program. I can see now, just by going through it, using the debugging tools here, I can see exactly what the program's doing without having to like look at all of these files and be like, well, you know, trying to piece it together manually is my point. I can just go through this and it's all easy. Next up, game.run, F11 to step into that. Okay, it's making a ground, it's setting up a few things. We are clearly adding this ground into this entities list here, starting the main loop, and then here's the main loop while window is open. So what's that doing? If I zoom out a little bit, we've got all of our time and event stuff. We've got is mouse button pressed. Otherwise, look at this, step into the physics and world.step. So that's a good kind of indicator, I guess, of where like the physics is actually taking place. And if I just hit F5 to run to my next breakpoint like that, because F5 resumes execution, and obviously if it hits a breakpoint, it's going to stop. F11 to get into that. Don't really care about time as seconds. By the way, here's a little quick thing. If we just go back here for a moment, sometimes there's a lot of different functions that are called on a single line of code, right? So delta time as seconds is an example of that. If I just hit F11, I accidentally made some changes, rip. When that happens, sometimes it gets a bit annoying. I could have hit ignore there, but let's not get into it. So if I hit F11, you can see it goes into as seconds and not world.step. Now I could obviously, if I go back to where I was, hit shift F11 to go back and then F11 again. And in this case, that wasn't too bad. It takes me into this. However, what can be annoying is if you have like, I don't know, 10 of these or like a few of them, right? Sometimes you just want to step into this directly without going anywhere else. How can you do that? Well, there's two ways. You can basically go into world.step manually and just set a breakpoint here or even here if you want. Hit F5 and you can see it will run to this, right? So it's going to skip any other functions, obviously, because I've just told it to run up until it hits this next breakpoint. The other thing you could do, though, is just right click and there's this step into specific menu option over here, and you can just choose here from any of the functions we can step into. So there's that time as seconds and there's that dynamics world step. So if we wanted to go there, we could just right click, step into specific and dynamics world step. The other really good benefit, I guess, of using this kind of stepping through the debugger thing is if you have a lot of like inheritance going on and like derived classes. So a lot of these are like that. You can see smooth position solver is a solver. It can be an absolute nightmare when you have like, you know, some kind of base class. Like let's just say world was a base class, but really there could be one of like 3 different implementations. You wouldn't just be able to look at world.step and immediately see which one was being called, if that makes sense. Because world is a base class and it could be one of 3 classes and they might all have different step functions. But of course, if you use the debugger, clearly your code execution knows which one is being used here. And so when you step into that, it will step into the correct kind of derived class. So that can be really helpful as well. All right, so from there, we can see what happens every single frame when our kind of physics world is stepped. So apply gravity will apply some sort of gravity force here, which of course you guys would know all about because you would have looked at Brilliant and seen all of their kind of math and physics classes. Oh, what's this? You haven't heard of Brilliant, the sponsor of this video? Brilliant is an amazing website filled with many courses on various STEM topics such as math and physics and science and computer science. Seriously, there's so much on there. Now, if I need to brush up on my math, which sounds like maybe I don't need that, but believe me, I do. My favorite place to do that is Brilliant. The reason being that all of their courses are presented in such a great, engaging, and visual way that it makes the learning really fun and effective. It's presented with these widgets that you can like interact with to see how the math works, and to make sure that you're actually learning and retaining the information, they will quiz you and get you to engage with the content to make sure that you are learning. Their library of math courses is huge and goes all the way down to this everyday math course, which is a fantastic introduction for those of you who are just getting into math and want it to be gentle. But don't take my word for it, check it out yourself. The best thing about Brilliant is that you can get started absolutely for free. Just go to brilliant.org/thecherno and take a look at their wide range of high quality courses. Brilliant have also been nice enough to offer the first 200 of my subscribers 20% off an annual membership. So definitely hurry and sign up. It's such a fantastic way to learn. Huge thank you to Brilliant for sponsoring this video. So our force is being applied. That's pretty cool. I mean, again, this is a bit of a code review, even though, you know, we've talked about this before. I just use the idea of a code review to try and teach programming. I think it's a good practical way to do that. But if we go a little bit back to the code review portion of this code, if you just think about it, minus this stupid C++20, like whatever on earth is going on here, I honestly hate this, but that's like, let's just kind of move it like that. This code is just so easy to read. Like, you know, we have a rigid body, we have a force, we get the gravity force of the rigid body, we multiply it with the mass of the rigid body, and then we call a function called apply force with the force, right? Like, this code is so self-documenting, it doesn't need stupid comments being like, apply the force to the rigid body, right? That does not need to be here, and that's what's so beautiful about this. Code should be self-documenting as much as possible. We write code in English. Even if it's C++ and that seems like a low-level language to some people, there are lower-level languages out there. And obviously by the time our CPU actually gets these instructions, they're just machine code and they're completely not readable. We choose to write code in a language that is readable. Why? So that we can read it as humans. And so that's why if you're being all cool, like with your little function, like stupid names like F instead of force, like just don't do that. Get into the habit of making your code as readable as possible. It's going to help you. It's going to help your career if you plan to work with other people. But again, even if you don't, it's going to help you because believe you me, months will pass and you will forget everything you ever knew. And so coming back to that and being able to read your code and make sense of it is just so beautiful. So I really like the fact that this person has written their code like this. Now, little side note here. So I can see there's a resharper disable 1 CPP style cast, which I'm assuming I don't use resharper, but I'm assuming this is just a way for us to disable like a warning. This is super annoying, first of all. I just think that that's absolutely ridiculous, the fact that we have to litter our code with this garbage to make that happen. Now, again, I don't use resharper, and I'm sure there's probably a way to globally disable that in the settings. But in general, what this is referring to is the fact that it's saying that I'm assuming we probably should have used like a C++ style cast, which would look like this if we wanted to use a static cast. So this, I'm assuming, is what you would use. Personally, I'm not a huge fan of CPP casts, and I know that a lot of people are going to disagree with this. That's totally fine. You do you. Like, maybe sometimes I would use a dynamic cast because of like the other properties that it might have, but in general, I like to just use this kind of cast. And it's obviously not an actual compiler warning. It's more of a resharper thing. So honestly, like potentially what I would do is disable it like project wide, or maybe there's a way to do it, but like, you know what I mean? Like, it's just annoying to have this comment seemingly every time, I guess. Like, how many times does this appear? Okay, only twice in your entire project for some reason. What, do you not do casts anywhere else? Were you specifically trying to just do a C style cast here, but you've used like C++ casts everywhere else? Yeah, I mean, that's interesting. If I do a little search, it looks like you do use static casts in other places. So I'm not sure why you didn't use a static cast here, because obviously that would have worked. It's, I guess maybe because this is a polymorphic type, you tried to do a dynamic cast, which it's not accepting. Probably because the base class collision body, yeah, it doesn't have any virtual functions. So the thing is, when you have something like this, you can see that now this works. So what I've done is body is a collision body. It's a pointer to this class type. But if I don't have any virtual functions there, it gives me an error. And the reason for that is because it's not considered a polymorphic class type, right? That's the error here, unless you actually have like a vtable there, which happens when you have virtual functions, which could map to other functions in the derived class. Because otherwise, if we just look at this class, like there's nothing here, obviously, that suggests it's a base class. because all the functions are here and they're all implemented. That maybe is what happened, just the fact that dynamic cast didn't work, so you were like, oh, I guess I'll use just a normal C-style cast. But remember that anything a dynamic cast can do, a static cast can also do. Static cast can kind of do anything you want it to, really. It's just the difference is dynamic cast would have verified that it actually was of that instance, potentially, and returned null if it wasn't, instead of just doing the cast and then you crash later because maybe the memory layout isn't correct or whatever. So yeah, I would probably, seeing that you use static cast everywhere else, which is fine, totally acceptable, I would just change the code to that and then get rid of these stupid comments because I hate them. One more thing that I'm going to nitpick at is this. I personally do not like structs to be used as polymorphic types. So this should, in my eyes, be a class. Now, why? There is literally no real reason for this. There's probably no real reason for most of what I say. However, the reason why is because, first of all, you have a public and protected section anyway. With a structure, you actually don't need this because it's public by default. But you do. So in other words, there's no benefit, I guess, because the only difference between a struct and a class is the fact that structs have public members by default if you don't specify like a visibility modifier, and classes are private by default, right? So if this was a class and I had nothing here, all of this would be private. But if this was a struct and I had nothing here, all of this would be public. That's the only difference. But you've got a public thing here anyway, which means that I can kind of use these interchangeably and they will work. But the reason is, like, I like to personally add some semantics to struct and class. So for me, structs kind of represent data-only objects, I guess. Kind of like a pod type, plain old data, but not like necessarily. Like, you can still provide functions there. Maybe it even has a constructor. So like a good example of a struct might be like vector2. Because I want to have, like, let's just say float x and y. You can see they're public because I'm trying to make the data transparent and accessible. And I'm not going to have private kind of areas here where I have like additional data or anything like that. Yeah, that's not kind of, this is already getting too complex. So I like to keep structs simple. That's the meaning that I just assign to them because in my eyes, it kind of makes sense. Structs are designed to be public by default, so it's just a way for me to tie variables together into a structure. That's kind of what a struct is. And of course, the reason they're like this is because structs map directly to C. C does not have class as a keyword, it's only got structs, and it doesn't have public, private, protected. There's no visibility modifiers in C because there's no objects really or classes. So you just wind up with structs being public by default because this is compatible with C. But of course, in C++, where we do have classes and we do have visibility modifiers, their use becomes a little bit, well, they're not needed, to be completely honest, because you can do the exact same thing with a class. There does not have to be two keywords, struct and class, where one of them is magically public by default and the other one is private by default. But yet we have this, again, for that compatibility with C, so that we could just include like a C file or a .h file that is written like in the C programming language and everything will compile fine, mostly because we have that compatibility in the C++ compiler. So yeah, this is one of those things where I like to assign my own meaning to it because it's kind of, you don't really need it. So we might as well take advantage of it. And that's kind of the meaning I assign to it. And one of my rules is that I don't have any kind of inheritance going on with structs, right? So in other words, I wouldn't have that rigid body. See, again, really annoying. I wanted to open up the rigid body header file. Of course I did. But there is no header file because you haven't included it in the project. So it's just rigidbody.cpp, and then I have to switch on over into this. And then here, obviously, it is a subclass of this, and you have public here and private, and like, again, it would function. If I just change this to class right now, the only thing I'm actually going to have to change as well is that if I go back here, I'll have to make sure this is public because otherwise it won't quite work that way with classes. But anyway, if these are the only two changes I make and I just compile your entire project, you can see that's done, right? I mean, I've only compiled this static library, but if we build demo as well, yeah, there we go. No problems, no warnings, nothing like that. Everything's beautiful because it's such a minor change. However, to me, when I look at it and I see that it's a class, okay, it's more of a complex type. It's not just like a struct of data. So that's just, again, very subjective, just my opinion, but that's kind of how I like to deal with like structs versus classes and trying to decide which, like, should this be a struct, should this be a class? Okay, and then if we quickly look at the apply force function, okay, pretty basic. This just does this. For some reason, you've got this here, but force plus equals added force. I don't know why you've done this because you haven't done it anywhere else. I'm sure it's just like a typo or something. But you can obviously just do this, same as you've done over here. This is another good example of why it's nice to have these you know, be called not just that, because it means that if you do have some kind of convention where you add something special out the front for members, it means that if you have a parameter of the same name, you can do this without having to use this. I don't know why I'm getting all these errors suddenly. It's probably just Visual Studio. Just Visual Studio being Visual Studio. Yep. It's just going to display these errors here until the end of time. Okay, whatever, you do you. But yeah, if these were called the same thing, like if I had force like that, and then this is also called force, then I would have to write, you know, this arrow force equals force, so that I can tell it that I'm referring to the member rather than the parameter name, because they have the same name, which we should ultimately avoid. And we can do that by having this little thing. I saw someone in the comments of the previous video was saying that they wouldn't do underscore, like they wouldn't have like a leading underscore because that's kind of reserved for compiler internal things. This is kind of true, although my suspicion is it kind of differs per compiler. Like for example, everything inside Visual Studio always has a double underscore, right? So whether that be like Visual Studio only or MSVC only function like debug break, or even like some kind of you know, like here we have like a variable type, which is just a like 128-bit SSE register here. Like that all uses double underscores. So for me, that's not that big of a deal. I suspect that maybe like in GCC or Clang, maybe they have single underscores. But me personally in my code, I always, as I mentioned, I use like M underscore. I don't just do underscore only. But yeah, I mean, I think that, you know, especially if you're using Visual Studio and you're compiling with MSVC, I don't think you'll get any problems with single underscores like this. All right, well, I've just spent most of today talking about like debugging and stuff, so I guess take 3 next time we'll talk about the physics. I don't know, you guys enjoying these code reviews where I just talk about code? I mean, I guess code programming, that's kind of the subject of these videos. Let me know what your thoughts are in the comment section below. But I hope you guys enjoyed this code review. If you did, please don't forget to hit the like button. Remember, you can send in your code to chernoreview@gmail.com. There are some instructions on how to do that and what like information to include in the description. You could be next once we actually get to the physics engine. Don't forget to check out Brilliant and learn something, and I will see you guys next time. Goodbye.